for big data, the big picture. So yeah, we're going to be looking at Scala, big data, focusing on Azure, data lakes and Databricks. But firstly, who am I? I am a senior advancing analytics consultant working with data engineering, cloud, MLOps. I've got over 14 years experience working in software engineering, most recently working with Scala, Kafka and various cloud tech. I've got a Bachelor of Science in Multimedia Computing and Business, a HND in Visual Communications. So I've been doing it a while. I'm really passionate about data. My LinkedIn link is at the top there, and then also my Twitter link as well, but I'll provide them at the end as well. So I'm involved with a lot of meetup and community groups, say Subject Data in Bristol, and then also Women's Tech Hub in Bristol. I get heavily involved trying to get more women into tech, get more women speaking at events and stuff as well. So we are going to look at Databricks in the context of Scala. Just bear with me 1 second. Why Databricks? Well, Databricks essentially under the hood is written in Scala, as is Spark, which is what Databricks is based on. So we're going to use that as our tool to actually explore Scala. We are going to look at case classes, map and flat map, options, reduce and filter. And then hopefully if we get time, we'll look at a real world problem, say third-party API providing old school XML responses that need to be transformed into JSON. So this is taken out of my day job. It was written into an event queue and then stored in a data lake. So very much in the Microsoft realms, we're going to be working with an Azure Function, data lake, and then essentially Databricks. Any code that I share is available at this link at the bottom on GitHub. So Spark and Databricks. As mentioned, Databricks has been derived from Spark, so it's important to have that understanding. So what we're going to do is we're going to step back in time a little bit and just see where Databricks and Spark came from. So back in 2003, Google releases the GFS, the Google file system. Google were facing a problem in that they simply couldn't find disks big enough and fast enough to store all of the data they had. So they came up with a master plan to chunk files up into, spread it across multiple disks. This became HDFS and the tech that is inside blob storage, Amazon S3 buckets and data lake store. 2004, now the data was nicely distributed, they still had the problem that a single computer had to read all of those distributed chunks. They had essentially removed the IO bottleneck and replaced it with compute one. So Google came out with MapReduce papers, which essentially did the same distribution, but for compute. So take a query, transformation, compute task, and break it up into different parts and give it to lots of different servers, each to perform their own chunk. So both MapReduce, HDFS, and a bunch of other stuff was donated to the Apache Foundation, became the open source project known as Apache Hadoop. There's a whole ton of different projects, languages, frameworks, etc. that now surround it, but the idea of MapReduce and HDFS are central to most of it. But there's a problem. MapReduce relies on putting the data down after each step. It's very, very chatty with the disks. So despite the amount of parallelism, it is not that fast and it's pretty hard to use. There is a big tech barrier to getting started. So this guy, Matti Zahari, started the Spark project in 2010. So doing a very similar thing to MapReduce, but with two very important differences: implementing a lazy executor, working out the most effective way to do things, and chaining tasks together. Doing it all in memory, which is a hell of a lot quicker. And so then they donated Spark to the Apache Foundation in 2013. But what do you do if you've invented an open source product and given it freely to the world? You essentially, you start a company that makes a premium version of it. And that's what happened. Databricks was formed by the guys who invented Spark, and they are still streaks ahead. Databricks has its own Spark runtime with a whole bunch of extra features, performance optimizations, and general improvements. So Apache Spark, and I promise you we are moving into some actual Scala code. We just got to cover Spark and Databricks first. So Apache Spark, this is just an illustration. Basically, this is some Azure tech, but you can transfer this over to other cloud providers, so GCP or AWS. We've got event hubs, IoT, Kafka on one side, storage blobs, so your data messaging services, your data storage blobs, Spark in the middle, so that's your ETL transforms, and then on the other side we've got things like Power BI, but that could say be Tableau, databases, data lake store, so AWS, say that could be S3, and the same with Azure storage blobs. And Spark has a lot of out-of-the-box connectors already. It's very popular, it's very established. So we've got things like MySQL, Kafka, MongoDB, Cassandra, Hadoop, HDFS, PostgreSQL. So all very common tools within the data realms. And once again, Databricks, just to clarify, Databricks is an organization and big data processing platform founded by the creators of Apache Spark. It was founded to provide an alternative to MapReduce. It was created for data scientists, engineers, and analysts to help users integrate the fields of data science. And just similar to the illustration for Spark, we've got our data scientists, engineering line of business on one side, the data on one side, and the other side, applications, so like deep learning, warehousing, Power BI, and Spark and Azure Databricks sitting in the middle, like your transformations, your ETL transformations in the middle. And along the bottom there, we've got Kafka, Hadoop, data lake store, blob storage. So, Scala. So as mentioned, Spark and Databricks are written in Scala under the hood. Why is Scala so good? Well, first things first, what is it? Scala is a programming language that is developed to allow you to write object-oriented programming and functional programming. Now, for those who know what those are or have a rough idea, you'll know that they're very, very different paradigms. So to merge them together, as illustrated here, it is a very weird marriage. And Scala, it isn't unique in doing it, but it is one of very few languages that actually offer this. Is Scala its ultimate teaching language? Well, the jury is out a little bit on this one, some may argue it. But what I'm putting forward is that we've got here Python on one side, procedural programming, interpreted dynamic typing, REPL, and then the other side we've got Java, compilation, static types, data structures, design patterns, C-style, and at the bottom here we've got functional programming, JavaScript, and then object-oriented programming, which is there overlapping the different languages. So how can we join all of these together within the programming realms? Well, Scala sits over all of these and offers all of these features. So essentially, if you're really serious about programming, Scala is a great language to get started with. So Scala and big, no wait, fast data. Scala has taken over the world of fast data. It's a quote I found online, which I loved, even though that's slightly dramatic. But Scala is great for big, fast data. And as illustrated again here, same diagram as I showed you a few slides ago. We've got our data source on one side, event hubs, Kafka, messaging, and then storage blobs, IoT hubs, and then Spark sitting in the middle, again written in Scala, and on the other side, Power BI, databases, data lake storage, and Azure storage blobs. So Scala essentially sitting in the middle there, handling all that big data and managing it. So, okay, so if it's that great, who actually uses it? So we've got some big names here. We've got Netflix, Airbnb, Twitter, Foursquare, Sony, and my absolute favorite is Disney Plus. My daughter absolutely loves Disney Plus, got The Simpsons on there, it's great. And it's awesome to know that that's actually written in Scala under the hood. So what software is actually written in Scala? I know I'm sounding like a broken record, but yes, Databricks and Spark. But then we've also got Kafka, and then two others here that you might not have heard of within data realms. We've got the Play framework and Akka, which are two very popular frameworks for Scala developers. So, but still, why learn Scala? I've done my sales pitch. Still, why do you want to actually learn it? You could bury your head in the sand and say, no, don't want to learn it. I've got my Python. I'm fine. I don't need it. But for example, as mentioned, if we've got Spark and Databricks written in Scala under the hood, you will find when working with them that you are going to have to dip your toes slightly in Scala, even if it's just to start working with some of the packages out there to actually do what you need to do for your transformations. But still, why bother? Scala is basically gives you transferable and portable skills in your day job. It's a competitive skill set. It's multi-purpose, so that means you can use it from anything from simple web app to machine learning. It has a solid community behind it, so lots of support, lots of information out there for you to help you learn and to support you. It is type safe, so I'll move on to that in a second, what type safety actually is. And essentially it allows you to learn functional programming in a nice bite-sized way, friendly way. Type safety. So type safety means that basically the compiler will validate types while compiling and throw an error if you try and assign the wrong type to a variable. Now, for a lot of you, what does that mean? That could literally be a load of gobbledygook to you. What it means in layman terms is essentially you can't turn a cat into a dog. So if you've got a string, you can't suddenly decide that that's going to be a number. If it's a string, it's a string. If it's a cat, it's a cat. You can't suddenly turn it into a dog. And that's essentially what type safety means. So functional programming, I'm not going to go too deep into functional programming because it's a deep subject. And I know a lot of you will switch off if I start going on about category theory and all the realms around functional programming. But we will briefly just look at some of the core concepts of functional programming, immutable data, closure, first-class functions, maintainability, modularity, referential transparency, and then category theory. Very scary, don't worry, we're not going to go into all of these, but we are going to look at one of the core favourites in functional programming, and that is monads. So functional programming and monads. A monad is a sequence of events with a get out of jail card. So if we have step 1 in our code and step 2 in our code and step 3 in our code, at any of these points, we can actually break out. So our get out of jail card. So if something happens that's unexpected, we don't get the result that we expect, we can break out of that sequence without having to have a big try catch around what we're doing. A monad is designed to handle that for us. So it handles it in a nice, neat way, and we've got less error handling having to happen because we've designed it to be able to cope with that. So what are we going to do? Just to clarify again, we're going to look at some case classes, options, pattern matching, map and flat map, reduce and filter, for comprehensions. Now this is just stuff that you'd have in your belt as a Scala developer, just some of the basics that I'm going to go through. So nothing too deep, but just to help you gain a basic understanding of what Scala is, and what you can do with it. So first things first, case classes. Case classes are good for modeling immutable data, and they act like blueprints. So they are your models, they are the blueprints of your data. So without further ado, let's actually get into some coding. And sorry if I'm rushing a little bit, I'm very conscious of time. I'm open to questions at the end, or just message me, it's absolutely fine. So case classes. So I'm going to do a little bit of live coding, but because of time constraints, I probably will be doing some copy and pasting and just showing you some that I've made earlier. So what we'll do here, as I've defined a case class here, and I've defined a case class of employee. So we've got employee with a first name and a last name. And then if we just run this cell, oh, sorry, really sorry. This is Databricks within the realms of Azure. So this is Azure instance of Databricks that I've spun up. And this is one of the notebooks that I've created to be able to demo the code to you today. So we'll just wait for it to attach to the cluster. and just pray to the demo gods. Okay. Hold on. Right. Sorry about that. It was running as Python. We want Scala. Right, so we've defined our case class, and the output here is basically saying we've defined a case class of employee. So then what we can do is we can create an instance of that employee class. So I'm saying val employee or emp equals employee and Ada Lovelace. So providing a first name and a last name. Output employee of Ada Lovelace. So then what can we do with this case class instance? What is the magic that we can work with? So first things first, I'm going to show you hash codes. So I've done my employee.hashcode. What is that? If you've worked with hashing before, this may be familiar to you. A hash code is essentially, in this instance, it's getting all of the data out of our employee instance, so Ada and Lovelace, and hashing it. So we can hash the data and then compare it at a later date to see whether anything has changed. And unlike in other languages, where if you were to compare objects, it just compares objects, with case classes, actually, when you're doing a comparison, you are comparing the data within the object, which is one of the actual beauties of case classes. So now what we want to do is we want to take a copy of our employee. So that is simply a case of doing emp.copy, and it gives us a copy. Why would we want to do that and not actually just say change a value? Well, once again, case classes are immutable. You can't just go in and start manipulating the values of your properties under the hood, your first name and last name. It's immutable. So if you want to actually change the values, you have to create a new instance of your case class, your instance, your original employee instance, and create a new one. So we've got this copy functionality that we can work with. And if you want to actually start manipulating the values in your new instance, you literally specify it. So you say first name is actually now going to be Dave. And just to illustrate that you can't just change the name without creating a copy, if we attempt to run this here, this emp2.firstname, or we could say you cannot reassign to a val. So how does this compare, say, to Python, which I'm sure a lot of you are very familiar with? So we've got some Python code here. By putting a percentage sign in Python, it basically means in this cell I'm able to write Python, even though this is defined as a Scala notebook. So what I'm doing is I'm saying emp here is equal to true, and then we can just comment out this. See, the output is true. But what we can do with Python, which may be a desired feature for what you're doing, but for a lot of very heavy data engineering, this can introduce bugs. You can actually then say emp is actually Dave. So you're not only changing the value, you're changing the data type. And Scala doesn't allow you to do this, and that's what we're illustrating in all of this example code. It's immutable and you can't change the value. Okay, so options, moving away from case classes, options. options handle empty values without error. The null mistake, I call it my $1 billion mistake, was the invention of the null reference in 1965, Tony Hall, 2009. So he's saying that nulls are actually a bad thing when working with programming languages. And I think a lot of us who, when programming, we've had that null exception pop up and been the bane of our lives. We're saying in functional programming that we don't believe in that. Nulls don't exist. So we work with things like options to actually handle empty, what would be null instances. So a Scala option holds 0 or 1 elements of a type. So essentially what it does, it's going to return as a sum or nothing. The easiest way to illustrate that is actually to show you the code. So because of time, I think I might actually show you the one I did earlier. So what we've got here, once again, a notebook in Databricks, we are defining an option. So we're saying here, val a option, it's got a data type of string. So you've got type safety there again. And we're saying it's going to equal to sum, and that's our actual value. And then we've got val b option string is equal to none. So what can we do with this? What does the magic it gives us out of the box, the same as what we were saying with case classes. Once again, attaching to cluster. Bear with me a second. So what we've got here is we've got an out of the box is empty feature. What does that mean? Well, it's basically what it says on the tin. It's basically saying, let me know if this is empty or not. So is A empty? Well, no, we've actually defined there's a sum there, so it's not going to be empty, but B is in fact empty. So we will get a result telling us that there is nothing in there because it's returning us a none. So if I just comment this out a second, we've got a Boolean here of false. So no, it's not empty. But if we do B, we get a true. So here we're doing a bit of pattern matching. So we've got basically a function we're defining of show match. We're taking our option result. We're doing a case. So if we've got a sum, we return the value. But if we've got a none, we were going to return a question mark. So this is one of the nice ways we can actually work with our options and actually do something a little bit more clever with how we handle those empty values. So it's saying show match B. We know B is empty, so it returns as a question mark. But you can also do a very simplified way of doing it, and out of the box way of doing it is we could do a get or else. And that's literally what you get out the box with Scala. And we're saying get or else give me a question mark, but A actually has a value, so we are returned value because that's what we've got here. And in a nutshell, that's what options give us out of the box. Okay, so moving on to map, we're going to cover map and flat map, and it basically opens the box of data and transforms it accordingly. Best way to illustrate that initially is just to show you the code itself and what it's doing. So not a lot of code, so not too much to have to read through. We're defining a val again of A. We've got a list. List is the same as what you get in loads of programming languages, in C#, in Python. We've got a list of 1, 2, 3, 4, 5. And then we're going to map that list. So what we're saying here is we're saying for every value in our list, we're going to map it, the value, and then put it within a list, and then append a 0. So as you can see here, I've already run this command earlier, and what it returns is, from this list of 1, 2, 3, 4, 5, is a list of lists with 1, list 2, list 3, list 4, list 5. And the question is, why have I shown you this? Why have I put a list within a list? Because this is the perfect way to actually illustrate what flat map does. So flat map actually takes that list of lists and flattens it. So it says, I've got a load of lists within a list, but I just want the list of numbers. So it flattens it all, it gets rid of the extra lists, and it returns us a list of 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, because essentially that's all the values that we've got here. So hopefully you'll be able to see how this can be applied really nicely within your ETL transforms when working within data engineering and munging all of your data. So if that still doesn't make sense to you, that's perfectly fine. I've got map explained with emojis here. So simplified form, map, you've got a cow there, a potato, a chicken, some sweet corn, you're going to cook it. And the result is a burger, some chips, chicken egg, and some popcorn. And flat map basically opens the box of data, transforms it, and flattens it, so stamps on it. That explained more simply using cats, because you've got to have a cat slide. We've got a cat in a box, and then a box in the box with another cat in it, and that's essentially an illustration of when you fail to do flat map properly. So you wanted 2 cats in a box, but you've ended up with a cat in a box and a box in the box with a cat. Okay, so reduce and filter, so that sums everything up and only gets the data you need. So quickly moving over to look at some of the code examples of that. So we're defining a val of x, we're going to say that's going to be a list. This range is literally just saying it's a range of 1, 2, 3, 4, 5, 6, 7, 8, and 9, as illustrated here, where I've already ran these commands. And then we're saying, right, I want to filter, and I just want all the evens. So anything divisible by 2 equal to 0. And that gives us the result of 2, 4, 6, and 8. So filter is very much the same as you've come across in different languages already. It's just illustrating that it's there out of the box for you in Scala as well. And what about reduce? So I've got my sequence here. A sequence is very similar to a list. And we've got a sequence of 3.5, 5.0, and 1.5. And we're going to apply a reduce on it. What does that mean? Well, what we're going to do is when it reduces it, it actually adds them all together. So by doing A plus B, we are essentially going to get 10, because 3.5 and 5 and 1.5 added together is 10. So once again, the emojis, just so that makes a little bit more sense to you if you're confused. Filter, essentially a burger, some chips, chicken, sweet corn, saying, is it vegetarian? Chips and sweet corn essentially are vegetarian. And then reduce, we've got a burger, some chips, some chicken, and some sweet corn. And if you reduce it, you end up with poop. Okay, so moving on to monads, which I mentioned earlier, that little thing we've got within functional programming, one of the functional programming's favorite tools. So we're going to look at a full comprehension in Scala, which is a monad, and we're going to see how that works. So full comprehension in Scala. So you don't have to worry about all of this. This is just me importing a load of packages that I want to work with. We've got our employee case class again. This time we've added an age, but essentially it's the same concept. We're saying this is a load of XMLs that I'm going to feed in, and I want you to actually spit out the JSON. So this is, once again, as I mentioned earlier, what I've taken out of my day job that I've simplified, and I'm just illustrating this to you here to nicely show you how a monad can be utilised and how it works. So what I've got here is some boilerplate functionality this is just a try with, it's going to try and parse the XML. This is my parse function that will call the try with, trying to parse the element of the XML. And this is just some functionality that's actually going to try and find the elements within the XML. So don't worry about this too much. I have provided all of this in the Git repo, and the link I'll share at the end. And this is just trying to find nodes within the XML as well, and gives us a custom error message. So this is what we're interested in, this functionality here. So this is basically a full comprehension. We've got our XML that we're parsing in, so we've got that as our payload. And then here are all our steps. We want to grab our first name, we want to grab our age, our last name. And then if all of these are successful, we are going to yield an employee. So yield basically means if all of this happens, okay, if all of these steps are sequentially happen, then we can yield an actual employee instance. So what happens if this doesn't work? Well, here we've defined that the return type is a try. And what a try in Scala does is it's either going to return as a success or a failure. So it's either going to return as a success, where we've yielded an employee, or it will return as a failure. So okay, so we've got our XML payload here. We're going to get a result from that. So we're going to say, can I actually transform this payload? And then we're going to say get or else. So we saw this earlier, this get or else functionality. We're going to say get or else return a 0. So if we can't get it, then just return me a 0. I know this is going to be a try type. But what you can do is actually further down here, you can actually work with that successful failure out of your try. So you could do transform XML here with your payload, do a match that we looked at earlier. So pattern matching, and actually say, if it's a success, then just return me the value within it. But if it's a failure, then I won't get, in this instance, I'm actually going to print my failure. But this is where you could have some sort of logging functionality in there, some sort of alerting going on. So how am I doing for time? Okay, right. So we've looked at 4 comprehensions within the context of just simplifying in a notebook. Like I said, this has come out of my day job. So what I'm going to do now is actually show you the same functionality. And please let me know if you can't see this very well. Within the context of an Azure function. So here we've got a 4 comprehension again, exactly the same. We've got our XML. We've got our first name, last name, and age. We're trying to extract that information out and yield it into an employee if everything is successful, if we go through all those sequential steps. And then if that is a success, what we have got here is not a try, we've actually got an either. And what the either is doing is it's saying I'm either going to return this error, which is a case class that I've created, or an employee, which again, it's a case class I've created. We're yielding an employee, or we're going to return our own custom error object. So don't worry too much about all of this code going on here. Like I said, this is in the Git repo, but essentially this is an Azure function that I've prepared earlier, which I've already deployed into Azure. So here, this post URL here is the instance of the Azure function that I've already created. So if I hit send on here, and I'll just show you, sorry, the XML here that I've created. So this is my XML. This is name, my first name, last name. Obviously, that's not my age, but we'll just let that slide. So first name, last name, age, and then what we're sent back is the JSON. So first name, last name, age again, but within the JSON format coming out of our case class, essentially, an employee case class. So what happens if it doesn't find one of the elements? So what happens is the age isn't there. This is our custom error that we saw earlier in the notebook, and this is living within the Azure function as well, exact same functionality. It's telling us in a nice, neat way, could not find element, cannot find unique child of age. So that's our monad kicking into action. It's got to a certain point, can't find the age, and so it spits out the error instance for us, that error instance of a case class. So now we want to actually work with this, once again within Databricks, but we want to bring Azure Data Lake Gen 2 into the mix and see what we can do with that. So if I just briefly show you here, this is an Azure Storage Explorer. This is an Azure Gen 2 Data Lake instance here. This is one of my blog containers, and I've already created a raw folder. And within the raw folder, this is conventional Data Lake file folder structure. So we've got year, day, month. And then this employee.json, this is exactly what we were just looking at. So this is where that transformation has happened from XML into JSON using our Monad. And we've literally just pushed this into our Azure Data Lake. And now we want to actually do some work with it using Scala. So here, we are actually connecting to our data lake. So that's what this is doing here. We're doing a Spark read JSON, giving it the location we were just looking at, so that raw location, 2019, 10, and 1. And we're going to say this is going to be an employee. So we defined our case class. We know it's going to be an employee. So I'm saying grab me this as an employee. And because this is a demo, I've just literally put together some existing employees, hard-coded it as a list. So we've got employee 1, me again, employee 2, Bob Smith. And we want to actually say what we're getting out of the data lake, is it actually matching? Have we got a match between these two JSON objects, or in this instance, employee objects? So what we can do is we can say existing employee IDs and then filter. So we looked at filter before. We're going to say, does the ID of any of the employees in this list match our new employee? So for demonstration purposes, we're just getting the first here, the first row, and we're saying, is this ID equal to that ID? So if it's equal to 0, we're saying, well, it doesn't exist already. So basically, we want to actually just write it into the lake. It doesn't exist already. You don't have to do any comparisons at this stage. So literally, we're writing into lake at this stage. So at that point, we're not going into raw. We've got another folder refined. Once again, standard data lake structures. We're going into a refined folder, and we are actually writing this file, treating it as a new instance. So what if it's not a new instance? Well, what we do is we say, well, if it isn't a new instance, we know it already exists. Are we looking to see has anything changed in any of our data? So is the first name changed, the last name changed? So what we can do then is we can actually work with our hash codes again, do our comparisons between case classes. And that's essentially what this is doing here, is actually doing a comparison, saying if it doesn't match, so that's saying if I don't actually find a match, so if there's actually changes in the data, we can then write that change into the data lake. And within here, you can do whatever logic you want, whatever transformations, ETL transformations you like within here. This is just a very basic example of doing that comparison, and actually then you're able to start working with it. So we can then write it into that refine folder. So I'll just quickly show you the refine folder whilst we wait. So you can see here, there's nothing actually in our refine folder at the moment. Just wait for it to attach to cluster. Okay, so now this is run. It should have found that it found a match on the ID, but the data is actually different. So in our data in the data lake, it's got a different age. So it's actually going to write the file into the refine folder. So if we go in here and do a refresh, you can actually see now that it's written the files in here. So we're interested in this one, this .json file here. This is basically Spark breaking the file down. That's why it's got a part -000 and the rest of the GUMP. So don't worry too much about that. But that's essentially, that file has now been written into the lake. So hopefully that's made sense, and apologies again for the delay at the beginning, technical issues. Useful links if you want to learn more about Scala. So I appreciate I've rushed through a lot of stuff there. So I don't expect people to understand all of what I've covered. but I've got some useful links here, resources that I go to on a regular basis when I'm working with Scala. So we've got Scala exercises, Scala EPFL, Coursera is really good. There's some really good courses on there. CAT's library is really good when you're actually working with Scala and teaches you a lot about functional programming. Medium.com, Disney, as mentioned before, I've got a really good blog on Scala if you're interested in learning Scala. Conferences, not really happening at the moment, but normally I'd look at going to Scala Days, Scala World, and also Scala Exchange is really good. So, yeah. Right. Yeah, so thank you very much for listening to my talk. I hope that was useful and interesting for you. These are the links, firstly to the code that I've shown you, my LinkedIn account, my Twitter account, and just message me if you've got any questions. But I'll be here for the next 10 minutes or so to answer any questions that we've got in the chat.
Okay, thanks very much for that, Anna. I hope everybody can still hear us and everything. I just want to personally give you a big clap. Great recovery there. I'd definitely struggle after some technical issues. Definitely hard to find your flow again. So well done for that, and much appreciated. I'd just like to start off with a personal question, perhaps something a little bit more sort of general. It was plain to see from the talk that the benefits of Scala, which I also pronounce wrong, as I always do, is the sort of distributed sort of side. Now that makes sense. Just to ask you, I mean, where would you see the benefit for a data scientist or data engineer with functional programming as opposed to object-oriented?
So functional programming, in theory, and in practice, because I've used it quite heavily, it is less error prone than object orientation and procedural programming languages. So if you've got a massive data engineering project, I would personally lean towards working with Scala, the type safety Scala for the functional programming, because it's more robust. So not necessarily for data science, but for data engineering, when working with a lot of ETL transforms, my personal approach is to go more down the Scala route, especially if I were to be working with Databricks, Spark. Scala is my tool of choice. So unless a client particularly wants us to work with Python, I personally lean towards Scala.
Okay, no, that's great. And to follow on from that, we had Annika Rings. She's asked, it seems like Scala is the most popular functional language in data science. Is this true? And what makes it better than, say, Kami or Haskell?
So Scala's popularity has come a lot from the fact that it's Spark and Databricks use it under the hood. It's written in it under the hood. So that's kind of promoted Scala first and foremost as the functional programming language of choice. Scala allows you to do object-oriented programming and functional programming as well. So it's a lot gentler introduction.
Yeah. You can dip your toe in and then whip it back out again if it's too hard. Yeah,
you can have a go at writing a Monad, but then still do some object orientation around that and just slowly learn it. It's a bit of a kitchen sink language. It's got everything thrown in, so that can make it tricky. But it is personally, it's a great language to start having a play around with.
Brilliant. Okay, just quickly, I think we can sum this one up. Devon E. Jade asked, what would you recommend as learning resources for Scala? I believe that there was a list of resources in one of your slides, which will be available to share at the end. So Nayar Kazmi has asked, how is a monad different from try blocks in other languages such as R or C++?
So a try block, a monad is basically, it's a sequence of events. It's linear. So it gets to a certain point and it breaks out of the scenario in the way that you define it. So it will, like I showed you with the either or the try, I'm saying with the either, I've defined this error case class that you can break out of with, and you're coding around that scenario. You're not putting a big try catch around it and saying at some point this could break, and here's why all my catch instances that I think might happen. You're actually preempting what the scenarios could be for it to break. So that's the beauty behind it. Is with functional programming, it's
more flexible.
Yeah, it's actually planning that and making it more robust with your type safety, implementing your monads. So you're coding ahead of time, you're planning it ahead of time rather than putting the try catch around a block of code after the event, after you've created the code and saying, catch, I think these are the set of scenarios that might happen. So here's my different catch scenarios.
Okay, lovely.
Hopefully that makes sense.
No, but it does to me. Hopefully to the person who posed the question as well. Now the early one from Carl Burns. Can you make more complex classes, like an employee that takes another class of addresses, or what are the options perhaps open to you within that class function?
Yeah, the one that I showed you is very basic. By all means, if you want to actually have a type of a class, that's absolutely fine. If I started doing that in my demonstration, I think I'd lose people.
Yes.
So I mean, I kept it very, very simple. But yeah,
all the regular sort of varieties of things can be put in there, and it's just a different way of building it up.
Yeah, it's like working with classes in different languages. It's just the case class is it's designed to be a model essentially, and for you to work with that as data as a model. So you can have normal classes in Scala as well, but a case class is your model.
Okay, I see. And here's a general one from me. If so, say we've acknowledged that a lot of people are pretty familiar with Python. So how hard compared to Python would you perceive it to be to learn Scala for data engineering and or data science? Is it much more difficult? Is it a little bit more? Is it, presumably with the functional aspects, there's going to be more things to learn, but is each bit harder, easier, about the same? What would you think?
You could start learning Scala without looking at functional programming. You could literally just do object orientation. If you just want to start getting familiar with Scala syntax and some of the different data types, working with vals and vars, you can literally just start working with it in an object-oriented environment and just ignore the functional side to begin with. So you don't have to deep dive into it. You can literally dip your toes in, start having a play and just see how you feel. I mean, especially if you've worked with C# and Java before. And when it comes to Python, with Scala, yeah, it's a lot stricter. You've got type safety. But hopefully it shouldn't be too hard to just literally start doing some simple if statements, and you can do normal try catches. So it's not too difficult to pick up, and then slowly dip your toes into functional programming if you think that's actually going to help you with your data engineering and your data science. And as I mentioned, you can do machine learning and stuff in Scala as well. That is definitely possible, and the libraries are out there if you want to actually start having a play with that.
Well, as is the case so often with these things, once you start feeling a little bit of benefit, then it makes the outlay of the effort of learning the next stage much more easy to take on, as it were. Yeah. Yeah. Okay. Well, we've got one from Burhan Sabuwala. Are there any libraries that you know of for bioinformatics in Scala?
Ooh, no. You can certainly message me directly, and I can ask some of my Scala gurus and see what they know. It's an interesting question.
Okay, well, I mean, yeah, if you don't have it to hand, it's fair enough.
Yeah.
But the guys in the background will be able to facilitate all of this stuff, so we can surely pass that on to you afterwards. Enco Ride has asked, what are the benefits of using Scala for machine learning?
It's going to be the same sales pitch that I've already put across in my talk, is that you've got the type safety, you've got the robustness. So when going into production, you potentially there's going to be less room for error if you're working with Scala. That would be the selling point. And I know some companies, say in Netflix, they do put machine learning models into production using Scala. Not always. I don't want to. I've not worked there, but I have been told through the grapevine that they do that. So. But it's entirely up to you.
Well, just from myself, perhaps is that when we were looking at the beginning about the sort of distributed aspect, if the training set is so large that it's distributed around various different locations, then perhaps you might also see some benefits there in the speed of
you could certainly then look at using something like Spark or Databricks with Scala to do it. But then, of course, you can also use Python in Databricks. So
well, that's one
it's
beautiful
weighing
thing
up.
about data science. There's always two ways to skin that cat. Yeah. Yeah.
Mhm.
Well, I mean, from my perspective, that I definitely learned something today and really enjoyed the talk.
Mhm.
Do we have any more questions there from internet land? I've answered asked the ones that were put up there. Give it a sec. But yeah, no, thank you so much. Really enjoyed the talk, and yeah, hope to see you on the Data Science Festival again.
Apologies if I've rushed through it really quickly. We had a lot of content.
You know, I mean, I think everybody out there is going to give you some. Anybody who's been, will the recording be shared? Frank, I believe the recording will be made available pretty quickly after the session's finished. Anybody out there who's ever given a talk, I'm sure will appreciate that it throws a spanner in the works when you have to.
Yeah.
Like that. I saw the thread going with lots of people giving you you know, sympathy and we've been there and we feel the pain. So thank you so much for that, and thanks to everybody out there for giving up some time. It's your most precious commodity. Much appreciated, and we hope to see you all in the very near future.
Thank you.